All right. What is up, everyone? And thanks for coming to hang out on the Auth0 channel. My name is James Quick, and I am a developer advocate at Auth0, and I am excited to welcome back. If you followed my personal streams, I say welcome back because we have done this recently about a couple weeks ago, but Ryan Chenkie, who has been all about React security as of like React specifically the last several months. I don't know how long you've been working on the content that we'll talk about, but then been in security for several years and worked at Auth0 as well. So anyway, Ryan, welcome to the Auth0 channel. Welcome back, I guess. And if you want to tell
Thank you.
everyone a little bit about you.
Yeah, totally. Thanks for having me back. Good to be here again and be chatting with you. So yeah, like you said, I used to work at Auth0. Worked at Auth0 from like 2015, middle 2015 till late 2017, and did some like DevRel type stuff there. Started out working on the content side of things, lots of blog content. Moved into kind of working on some of the product a little bit, like I was on a product team at one point working on docs mainly, and then I worked in DevRel before I took off. So that that was my time at Auth0, and I've been doing a lot of content about security and auth and that kind of thing since I learned a ton of stuff about it while I was there, and I started to want to dig deeper, and so I've been doing that ever since. And that culminates, I guess, now in this set of courses I've been working on lately, which is security stuff, auth stuff applied to React in a very very specifically in a React context, and what it might look like in the various flavors of that sort.
Sweet. Yeah, it's kind of cool. You mentioned like did some DevRel stuff. Obviously, that's what we're kind of doing here today, which I think is a lot of fun. And I'm going to switch over, and this will come through for people in a second. I'm going to show not JWTIO, but the course content, the stuff that you've been working on. First was React Security Fundamentals. And this is an absolutely free course, which I have gone through and absolutely loved. For anyone that is in the chat, if you just want to get some like really kind of the core stuff of authentication and talking about JWTs and protecting your React applications, even if you don't think you'll ever need it, you definitely want to check out this because it's not the kind of thing that you want to be unaware of. You definitely want to be aware of this kind of stuff. So that was the free course that you released a month, maybe 2 months ago. How long has that been now?
Yeah, that was back in May,
Okay.
Middle of May.
No. Okay. So it's been a couple of months. And then you just recently, this was last week or the week before, I can't remember, came out with the advanced React security patterns. And this just honestly is a much deeper dive covering some really cool technologies. And this is obviously why we wanted to have you come on and talk about security. But some of the things that you talk about in here are security with Gatsby and Next. And I want to ask you some questions about that as we go along. Things like refresh tokens, things like Auth0, which I actually want to give people a little demo of the new Auth0 React SDK, which is pretty sweet in my opinion. And anyway, so this is like a full paid course that I need to go through more of the content, and I'm super excited about it. And for the first time today in the stream, we're going to give away a couple of versions, or not a couple of versions, a couple of copies of this course to people in the stream with like a giveaway Twitch bot, which is going to use JWTs for people. Like everybody that enters gets a JWT, and you have to go and decode it out there for people that are interested. And then you can tell based on that JWT whether or not you win, and then you send that token back to me, and it's a whole thing. But I think it's kind of cool. And I guess, Ryan, to kick it off, I sent you a couple of questions this morning that I thought would be fun to talk about. And one is a pretty high level thing, but just kind of talking about maybe the 5 biggest missteps that you see, or maybe you like figured you needed to address in the course content that you put out over the last couple of months.
Sure, yeah. Yeah, so I mean, we're talking about it, of course, in a React context today, but this isn't like specific to React in the long run, right? Like this is for any framework, any library you might be using to build web applications. And some of the things that I see or have seen, they range from like really kind of what some might consider the basics of the basics, to more things that are more subtle, maybe some things that are not so easy to distinguish. And so I guess at the very like basic level, you could look at things like what you should be including or not including in the code that you ship to the browser.
Yeah.
So, so browser-based apps, the browser is a public client, and it's really got to be treated as a public client. It's got to be thought about as this place where once you send your code to it, it being the user's browser, once you ship them some code, you really have no control over what might happen at that point with that code. So what that means is like the user could go in and inspect your code bundle. If it's like really nicely minified and obfuscated and whatever, they can use some tools to undo that, and they can get a look into your code base. So no matter how much you try to make your code obfuscated and make it hard to read or whatever, it's really, you have to consider that as soon as the code that you write hits your user's browser, you've lost control over what might be done with it. And so what that means is it has a few implications. Firstly, we shouldn't be sending any kind of secret or sensitive information to the browser in the code bundle, because the user will be able to inspect it, they'll be able to see it. So, this ranges from the very obvious stuff like keys for, databases, God forbid, things like that. It goes into things that are more subtle, like maybe some private information that shouldn't necessarily be seen by all users out there. Maybe it's even some like parts of your page that in the right context could be used to kind of infer some things about what's happening on your back end or something like that, right? Like maybe some messages, maybe some default messages that might be shown at certain, when your application is in a certain state or whatever.
Can I bring up actually or ask you about one of those specifics? This was actually in your free course, and in a login process, if you kind of handle or are handling the login on your server, on your back end, you can respond back to the front end and give some sort of error message. And you can say, email and password don't match what's in the database. Or sometimes you see like email does not exist or username does not exist. And those are some things that actually give, like that one specifically, gives somebody that's maybe trying to hack in the awareness of whether or not that email actually exists in the database. So something as simple as like just a message that you give to the user for their benefit, just to kind of give some context, could be used in an inappropriate way.
Yeah, absolutely. And that particular point is one that's debated, because you could say like that it's a risk for you to start informing users whether or not certain emails already exist. So like say you come to sign up for an app or whatever, and you plug in your email, but you've already signed up before. Often you're going to see a message saying email already exists, you can't sign up with that email, whatever. So those, like that kind of error message can be used to enumerate different emails that exist in a service, right? So if if there was some application or website that it was a little bit dicey that you were using it, and somebody wanted to find out if you were using that thing, they could go and try your email in the sign up box, and they could see if you exist as a user in that application. So there's that case. There's many other ways that like enumerating users in a database can be detrimental in that way. But then there's this trade-off that says, well, if the user tried to sign up with their email and it already existed, maybe we say something went wrong or have some generic message, right? But that's not so great. Like that's confusing to the user. It doesn't give them a clear expectation of what they should be changing in their behavior to try to remedy the situation. So I think that's a specific example where there's this trade-off between what you should be doing to be security conscious and what is good for for UX. That being said, the messages that you would produce and like these fragments of data, these things that might be more sensitive, should, whenever reasonable, not be shipped in the code that goes to the browser. And so getting back to the whole idea of like keeping sensitive information out of the browser, you want your sensitive information, and that includes data that might go into power your application. You want to keep that behind a protected API. You want to keep that behind an endpoint that's got the proper checks in place to see that the call for that data contains the proper authorization information. And typically when you're coming from like a single page app, that looks like typically one of two things: either a JSON web token in the authorization header or in a cookie, or it's a session ID in a cookie that matches up with a session on the server. And that way you can identify the user making the request. So I would say, yeah, like one of the biggest ones and one of the more basic ones, it's stuff that shouldn't be in the browser. Make sure you don't ship it to the browser. Other things that we can think about would be like where you store your JSON web tokens. For a long time, the advice was you could store them in local storage, and that was fine. Some people still think this. Like some people, that's, you know, their opinion is that local storage is fine because, I mean, the issue with local storage is that you're susceptible to cross-site scripting attacks. So if someone was able to get some script onto your page that could execute some JavaScript, they could look into local storage, and then maybe they could ship your tokens to somewhere some remote spot where they would be collected. And so that's not good. We don't want that to happen, but some people have the opinion that like if there's cross-site scripting vulnerabilities on your page to begin with, then you've got other problems to worry about, not just the fact that somebody might be lifting your tokens. So their sort of stance is like, just don't allow cross-site scripting to be a thing in your application at all, which can be tough in some contexts. But I mean, that should be a focus, I think, of your security concern, is like make sure that cross-site scripting is not a thing that is a possibility on your page in your application. Because even if you don't have your JSON web tokens in local storage, maybe the user gets a script on your page which starts executing requests to your API on your behalf right from your browser, right? And then maybe that data gets aggregated at some remote location. So cross-site scripting is bad in general. Places where you can keep your token that are a bit safer would be like an HTTP-only cookie, or in your browser's memory, essentially, right? Like in your application state, which is kind of the advice now that Auth0 gives, right? Is to like keep tokens in your app state. Don't store them in persistent storage. And just every time the page gets refreshed or the token expires, just make a call for a new one, because there's this persistent session on Auth0's side.
And one of the
so that's another big one.
Yeah, one of the cool things about like the going and getting a token each time, for example, is from a developer perspective and a user experience perspective, you really don't have to do anything for that to happen. The Auth0 React library, which is hot off the press and ready for people to use, that you should check out, and we'll talk about a little bit later on, does all that stuff behind the scenes. So like as a developer, you don't have to do anything for it. As a consumer, you don't know that it's happening. You just kind of see that you are continue to be logged in when you refresh the page, which I always thought was really cool.
Absolutely. Other missteps, what can we talk about? So kind of along the same lines as the first one that I talked about is like, and this touches on performance as well as security. And that is that a user who isn't already logged into your application, or a user who doesn't have the rights to be at certain portions of your application, they don't need the code that goes into powering those parts of the app. So what we can do to prevent users from getting that code in the first place is we can do things like lazy loading. So if you're using Create React app, well, any flavor of React's got this lazy function now. It just happens to be easy in Create React app, but it's easy really in all flavors of React now. You can do lazy loading, which means that you've got these natural boundaries like routes that you can start to split your application bundle up. And if you split it and you lazily load the pieces that are necessary only at the times that they are necessary, you can do things like only ship the login screen when the application is first loaded. And then once the user authenticates, ship the rest of it. Likewise, only ship the stuff that everybody can see all at once. And then once an admin has authenticated, at that point, ship the admin related functionality, right? And so this will start to make your application perform better because it's smaller. The initial bundle is smaller, but it's also good for security because that code that's going to power those spots is left out of the initial bundle, right? So I think that bodes well for things on two counts. What else is a misstep?
One of the ones, I don't know if you've got two more ready to go, feel free, but I can.
No, you go ahead.
Yeah. I think one of the things that is especially confusing for people is thinking that like doing protection of some sort on your front end is the equivalent to doing just overall security. So what I mean is when you get into like private routes, right? Like on the front end, you can have a private route and you can potentially do like a redirect to make sure if the user isn't logged in, that they have to go to a login page, or if they try to get to an admin page and they're not an admin, they get redirected back to the home page or something like that. I think people see that. They're probably pretty used to that. But what you may not think about is like, even though I might prevent someone from going to that page in the browser, that doesn't stop them from like making a postman or a request in Postman or Insomnia or something, and like sending whatever the information is right directly to the server and just bypassing the browser. So I guess like for me, one of the eye-opening things for me a while ago, but then like more recently, just as I see people kind of take it in, is like security on the front end is really just a user experience thing. It's not actual security. All of your security really has to be on your back end to really prevent the things that you want to, if that makes sense.
Yep, absolutely. That's a key point. That's, like that touches on the point that the browser is a public client. It should be considered that like as soon as code gets there, it can be manipulated in certain ways. Like I've never gone to the extent to try this fully, but like one thing you could think about is that say you've got an application that's got like certain protections on the front end that allow for certain portions, certain states of the app to be shown based on like a user role. And say you made it really hard for users to be able to upgrade their role, which you should be making it hard for them to upgrade their role in the real world. But a user could take down all of your code. They could take down your code bundle and they could, deconstruct it. They could spin up your application essentially locally. And then they could start to mess around with the code in your application, which is checking for like an admin role or some elevated role. And in your front-end React application, they could then start to upgrade their privilege so that they could see what you would see if you were an admin. And so if they did this, hopefully you've got all your data protected behind your API so that like all that they would really see is just an empty looking kind of shell of an application, right? That's what you want. But I guess it's a key difference because like if you think back to like a round trip application, all of the authorization stuff generally is going to happen on the server before the constructed HTML gets wired up on the back end and shipped back to the client to see, which means you've got this authorization check in this round trip scenario. You've got this authorization check happening before any of the code that goes into power that front end view is actually constructed. Whereas if you flip it over to a single page application context, you've got this situation where you're just kind of like, all you've got to work with are these like hints that the user should be able to get to a certain spot or should be able to do a certain thing. You've really got no actual way to verify those things in a single page app context. So definitely something to be cautious about, I would say.
Yeah, absolutely. You gotta, there's a question in the chat that I thought you might want to address, and I think the simple answer is no, but it says, is there any way to hide JavaScript code from the client? And that's kind of what you've been touching on, but no, not really, right? Like no. If the code gets there, they've got access to it.
Yep, they've got access to it. They can fully see it. So don't rely at all on the browser like protecting your code. And so this is like getting back to the point we were talking about with the lazy loading idea. This was an interesting case that I was discussing with someone where their company was making an application that had to, they were monetizing like certain portions of the front end. And so you had to have like certain privileges to get to certain portions of this React application. And they didn't want people to be able to, find their way there, kind of hack their way to these like protected routes that they shouldn't be at. And if you think about that in like just a client-side context, sure, you can do lazy loading, which will help to prevent users from getting code before they're actually able to get it. But a savvy user, even if you're lazy loading, they can still say, okay, I'm going to try to hack my way to that lazily loaded route. And if it's just a simple check like, I don't know, is admin or like has a certain privilege, whatever, they can pretty easily manipulate that, and then they can trigger the server to load that route that was supposed to be protected. So with this, in this case, when I chatted with this person, what they did at this company is they actually they created like custom endpoints essentially for their lazily loaded portions of the application that would verify authorization before shipping that small bundle back to the application, like that small lazy loaded portion back. So they were doing protection on the API side, which you should always be doing. You should always protect your API routes so that data isn't released unless the user is authorized. But they were also requiring authorization just to release certain portions of JavaScript to power the client. So something you might think about. I think it's a bit of an extreme case. Like that's going to great lengths. But I mean, if the business requirements necessitate it, perhaps it's an okay idea.
Yeah, a lot of it. I don't know, working in enterprise software for a couple of years, you get some really interesting business requirements that you have to find creative and different ways to implement, I guess, sometimes. Mm-hmm. There's a question in the chat from Math Kale. What's the best practices for using external services that require client credentials, Firebase, Amplify, things like that? This is one of the things that I've been really focused on in my time is the idea of serverless functions, and I'm really glad that you cover those in the advanced course. People should go check it out and read up on. But I've always had this thing of like, if I wanted to build some sort of sample app, I could use something like Firebase. I've used like Airtable as an API. I've used FaunaDB as a database. And you get to like, you start to build an app and then you realize you need data, right? So then you look at, how do I work with this data thing? Well, I need like an API key or a secret credential or something. And you can't, to your point, you can't put those things in the browser. So then I move to serverless functions where I can then kind of use environment variables for those private credentials. So a lot of times, especially recently, the last several months, serverless functions have been my go-to of how to use those private credentials to then interact with whatever data source there is. Firebase has always been a really interesting one where you use the Firebase package. I don't know if you've worked much with Firebase, but you use it on the front end, like in the browser. And so you don't actually have the ability to use like a private credential. You're basically using just like an app ID and something else maybe to let this thing interact with Firebase. But the actual level of security that comes on top of that is like using the identity services in Firebase. And then with each request that goes back and forth on the database side in Firebase, you can control like a user shouldn't be able to delete a record that doesn't belong to them, that kind of thing. I guess the easy answer, or I guess the shortest answer is like, most of the time that stuff you just don't like. You either have to have your own server or you create serverless functions, and I just go the serverless route because they're so easy to implement, which is fun.
Yeah, with Firebase specifically, I think the advice has long been like, you want to control access via like your Firebase rules. Yep. So even though you've got this like connection ID that would sit in your browser, which users would totally be able to get, that they'd be able to get it, you're supposed to kind of control access rules based on like a user permission or a user role or whatever. And that's all kind of controlled ultimately on the Firebase side. One, I suppose, misstep that comes to mind that's worth mentioning in that context, and I've seen this, I saw this when I did an audit of a Firebase powered application, was that they had like certain protections in place for their Firebase rules so that like, if you were a user creating, data records under your own like account, I guess you could say, and the way that you would kind of like define that gets a little bit different depending on who you're talking to. Like you can consider it maybe like a tenant or just like an account, like a parent level account or whatever. What they had was like decent protections for how you might be able to create data, so that you could only create data under your own account. But they were missing, one of the things they were missing is like when you went to update something, it would take like the ID of the record that you wanted to update. So, okay, you get the proper ID, but they didn't have a protection in place there, which basically said that only users who owned that data could update that particular ID. So it was only looking for an ID and not like a data ID for that record specifically, and like a client ID for that particular user, like the organization or whatever they belong to, or even just the user ID, right? It wasn't checking in both places. So what you end up with, and this is a common thing to miss, is that like you might have like an endpoint that accepts patch requests to update some record based on an ID. But if somehow the user was able to like enumerate like database IDs, and God forbid your database is just like auto incrementing without, like
starting at zero,
starting at zero. So like, okay, let's update 1, let's update 2. In that case, if you didn't have that double protection, users would be able to just update any record that they came across.
Okay.
So that's an important one to think about. I think. I don't know. What was that, number 4?
I think that was 5. I snuck one in.
Was that 5?
Yeah, I said, have I been counting these correctly for people in the chat, by the way? I threw mine in there for 4. So it was like the front end security doesn't necessarily protect your back end. So that was the number 4 that I threw in. And that was on top of lazy loading was 3. Misstep 2 was where tokens are stored. And then 1 was be careful what you ship to the browser.
There we go. Done.
So misstep number 5, what's the summation of that? I can type it here in the chat for people to have.
Make sure that users can only update or delete data that they own, essentially. Okay. Because it would be very easy for you to create a database query which only looked for a record based on its ID and not on those 2 dimensions, which should be there, which is the ID, yes, but also that the user owns that data, right?
Absolutely. Yeah, very cool. You had another comment on from Sleepy Arpan about saying that he watched the interview that you did with Chenkie Dodds on YouTube. I need to go check those out, actually. I'm really excited to watch that. But I've seen Chenkie Dodds talk about this in the past, and it's the idea of like, instead of doing like multiple conditional checks inside of one component, like if the user's authenticated, do this. If the user's not authenticated, do this. I think his philosophy is basically like, not necessarily for every component, but maybe for a given page, you have like 2 different versions of the page. You have like the authenticated version of the page, and then you have the non-authenticated version of the page. And you only check the is authenticated part once, and then you display one of those 2 things. And I think I imagine a lot of it was just for like code structure and kind of reuse and like not having to do the if authenticated check a lot. Yeah. But I always thought that was like a really clean way to do that.
Yeah, totally. And it depends like how big your application is, how many times you're needing to make a call for like some function or method that checks for authentication or checks for certain authorization levels or scopes. You generally want to keep things as tidy as possible and not have to repeat yourself everywhere. So that can be a good way, splitting the application up. And one thing that we talked about in that interview was that you might, for your React application, you might even consider not having your login page itself be a React app. That might be something that's just like a JavaScript app or just like an HTML, like that is powered by form post or something like that, right? And Auth0's universal login, that's a good example of that. Like if you log into an application with Auth0, what you might want to do is not even load your application when the user first hits your domain, right? myapp.com, when the user first hits that. Maybe you run some code that's outside of your whole React application, which all it does is it checks for the user's auth state. And if the user's not authenticated, then they get it over to Auth0. And so what you have is like, if people are just trying to get to your domain just to see your code that powers your application, they're not going to get anything until they actually authenticate. So that's it's a decent way to have some front end protections. But again, it's just
front end protections.
It's just front end. It's like a glass house, right? Like it's not super. At the end of the day, your data, all of your stuff needs to be protected on the back end, and you can't rely on your front end to really give you any protection.
Yeah, it's a really interesting idea. The idea of separating out different pieces of your app, because in theory, like I don't think many people do this, but you could have a section of your app is React, a section is vanilla JavaScript, a section is Vue, a section is Gath. Like you could do whatever you wanted. And that idea or that concept has been, I've never really done it, but when I first heard about it, it was like really mind blowing to me. But I think for myself personally, I get caught up in like React is this framework and it does this thing, or library, whatever people want to debate, but React does this thing and that's what you use for web apps. And I never really like paid attention to like React is only doing its thing where you tell it to. So you can tell it to only do it on like a specific page or a specific section of a page and so on. So I've never thought about like abstracting some of your security stuff outside of React so that you don't even get the React application. That's a pretty cool idea.
Yep, it can bode well, for security, for performance. And you know, it would set you up for like an architecture that you'd probably see in like a lot of larger organizations where there's different teams working in different frameworks. I don't know how common that is, but I assume it's done at least somewhat.
Yeah.
And maybe various portions are just served up by various different JavaScript frameworks.
Yep.
Totally doable.